How many of you have done anything with Arduinos or hardware before? Okay, that's a lot of you. How many of you have never done anything at all, ever? Hands up, hands up. Okay, this talk is for you. And I hope the rest of you will learn something from it too, but really it's the beginner's guide. But first, I'm gonna back up a little bit. I'm gonna talk about why we want to do things like this. This is my cat, Tab Hunter. About 15 years ago, he was a wonderful cat, but he had a problem. He liked to wander. He would vanish for days on end, and I'd be walking around the neighborhood, where is my cat? Where the heck is my cat? I'd call, and I'd see him halfway up a palm tree. He'd slide down and say, hey, how you doing? I'm fine. But he was driving me crazy. I said to myself, wouldn't it be awesome if I could know where this cat was at any time? So I went to a hardware friend of mine, and I said, could I track my cat? Could I put like a radio on my cat or something? And he said, I think your cat's too small for a radio. Because this is about 15 years ago. Everything was larger and slower then. He said, you know what we could do? We could put 3 radios up in your yard. Like, you know, you could like put a transponder on the cat, and then you could triangulate, and then you could like have some base station that was gathering data. And I said, okay. I gave up. Like, it was too hard. But time passed, as it always does. And Moore's Law did its thing, as it always does. And last year, my employer had a hardware hack day. And I said, okay, I've never done this before. I'll go to this hardware hack day, and I'll see what's happened. And it turns out that in the last 15 years, everything is a lot smaller, a lot cheaper, it needs a lot less power, and it's a lot more accessible. And what's more, this awesome thing has happened where people have decided that hardware hacking is fun, and they've taken steps to make it easy to get into. I had this idea. There's my current cat, Mina. She also likes to visit the neighbors. I said to my neighbor at the hack day, do you suppose I could track my cat? And he said, yes, it's really easy. All you have to do is put a GPS logger on her, and it'll fit on a collar, no problem. That thing on the end there, that's a GPS logger on a cat collar. And that's an Arduino on a cat collar. And that's a Bluetooth module on a cat collar. That, my friends, is a cat that's about to be tracked. Okay. But I was terminally confused that first day. I actually didn't know what I was doing. I did not emerge from my first hardware hack day with a working cat tracker. I spent the day completely baffled about what I was doing, what was running where. And also confused about why this was a JavaScript hack day, but I was writing C++ that ran on an Arduino. Where's the JavaScript run when you write this stuff? How does it all work? So this talk is going to be about hacking hardware. It's going to be about Arduino, a little bit about Raspberry Pi. It's going to be about a piece of hardware you've never heard of called the BeagleBone. And it's going to be how you select among them for your project. And then the basics of hardware manipulation that they all have in common. It's like the starting point of how you get from the idea, I want to track my cat, to the reality of what you do. Is there something you guys want to do, a hardware project you've had? Somebody got something? This is Cat Tracker prototyping in progress. Okay, let's start. The really interesting things is hardware input and output. What the Arduino and the Raspberry Pi have in common, they're very different platforms in many ways, but what they have in common is how you hook hardware up to them. How you take a GPS logger and you hook it up is the same for both. How you take a temperature sensor and hook it up is the same for both. How you take a moisture sensor and hook it up, same for both. So we're going to start there with inputs and outputs, because that's the awesome thing about hardware hacking. It is a connection to the physical world. Most of us are browser programmers or server programmers. We don't do a lot of stuff that touches the world that's right next to us. Or if we do, it's in these lumps. Like this phone, it's a lump. I can't do anything with it other than what the designers have already decided I can do with it. But what you add to a microcontroller is the cool thing, and it's why you do this. All right, I'm going to start with some jargon. This is jargon you'll need to know. General purpose I/O, aka the GPIO. It's the pin. It's actually not a pin, it's more like a socket that you plug a wire into, but that's the place you hook up to. And you hook a wire to it, and then you hook a wire to a sensor, and then there's a changing electrical signal on that line, and that's how the CPU knows, how the CPU gets data. Or you make the CPU change the signal that's running on that wire, and that's how data goes from your microcontroller to the outside world. And that is the superpower of microcontrollers like Arduinos. It's what they have that a regular computer doesn't have, or it does, but it's hidden from you and hard to access. On an Arduino, it's right there. It's got a lot of them, it's out there, it's ready for you to hook up to. And that's what makes the Arduino and the Raspberry Pi similar and different from the phone in your pocket. Okay. Now we want to hook something up to our Arduino. How are we going to do it? This is the most confusing thing at my first hack day. The breadboard. It's just this like plastic plate. It's got holes in it. It's got wires behind the holes. You poke jumpers in and you make electrical connections. Key point, these guys are connected. These guys are columns, they're connected. You put power into the plus here. It's always plus, usually with a red wire, traditionally. And anything you tap off of there gets that power. Same thing with ground. Ground is always traditionally marked minus, usually with a black wire or a white wire, but that's just convention. You can use whatever color you want. These guys are all connected. And then the rows are connected. These guys right here, all connected to each other. So if you plug something in here, you can make a connection from here to another row. And the two halves of the breadboard are separate. Okay, breadboard 101. Power columns connected, data signal rows connected. And that's how you can prototype and make things work. Here's an example. Here's the simplest example there is. This is an Arduino turning an LED on. It's very exciting. Power, look at this. Unconventional green wire. From the Arduino to a resistor, to the long arm of the LED, and then the short goes into the ground, and then ground, boop, over here to ground on the Arduino. That's it, that's a circuit. You're in business, that LED is turned on. It's also kind of boring, because that LED is always on. Who cares about an LED that's always on? What's interesting is if you control that LED with software. Suppose you're turning it on when someone presses a button. Or suppose you're turning it on when your Travis CI tests fail. I mean, you're getting data from an external API. So that's what you do with the software. And that's why the microcontroller comes into business. Now we're going to make that microcontroller work. We're going to get data in through the GPIO, and then we're going to make decisions, and then we're going to write it out. Now let's go for Arduino. Everyone always says, start with Arduino, and I'm going to tell you, start with Arduino, get the SparkFun Inventors Kit. And the reason is that the Arduino was designed for you to start with. It was designed as a platform to teach hardware hacking with. This is awesome. If you want to learn it, start with the platform that was designed for it. The funny thing about the Arduino is it's essentially a late 70s computer. It's an 8-bit CPU, 16 megahertz, it's got 32K memory. The only reason you know that the year it was made in starts with a 20 instead of a 19 is that 32K is flash instead of volatile memory. But the awesome thing that it has is 14 GPIO pins, which is a lot of places where you can hook up sensors or motors. The sad thing about the Arduino, it comes with this really easy to use IDE, but what you do is you write C++ to run on it. You compile it with the IDE, you download it over USB to the Arduino, and away it runs, which is, you know, great. Here's a typical circuit for the Arduino. Here, let's get some decision making in mind here. I made this the other night as a demonstration. Here, I'm using the traditional red for the power. and then brown for the ground. You can see power goes here. Everything's connected along this column to the breadboard. Tap off a resistor over to the input on the button. And then the button goes whoop, whoop, and back to the Arduino's ground. Everything shares a ground. The one thing about electricity I want you to walk away from this with, share your grounds. And then here is the exciting thing. This is the data signal from the button here, connected across this row. And this is the fabled GPIO pin right here. That's where the signal goes. You probably don't understand how I wrote this circuit. I didn't understand how to make this circuit the first time I did it. What I did was I went off from an example on the Johnny 5 website. I'll get to Johnny 5 in a moment. But this is how you'll get started. You'll take other people's circuits and you'll build them. And then you'll build large projects out of lots of little circuits. It's modular. It's like software, only it's frozen. Okay. Now, we're about to just get the JavaScript into it because C++ is okay in Arduino byte sizes, but this is a JavaScript conference. We want to write JavaScript. And here's how we do it. Johnny 5. There is a standard protocol for talking to these hardware devices over a serial port. It's called Fermata. It comes, our implementation for the Arduino comes with the Arduino called standard Fermata. You've got it already. If you've got the Arduino IDE, you have standard Fermata. You choose it from the sketch list, you download it over to your Arduino, and then you walk away from the Arduino IDE because you're writing JavaScript in your favorite editor from this moment on. npm install Johnny 5. Fire up your favorite text editor, and then you write code that looks like this, which is beautifully familiar. This is Node. We require the module. We make a board object, which is doing an enormous amount of magic behind the scenes. Behind the scenes is a Node implementation of the Fermata protocol at the other end. We create a board object. When we get a ready event, another really familiar pattern, we can do things like make a button object. And you'll notice here's that famous pin 8 that we went into and the other thing. All of these things are magic numbers in the Johnny 5 source. And then we can do this beautiful thing here. We get an event when the button goes down, and we can do something. We get an event when the button goes up, we can do something else. Here I'm just console logging, but you can imagine doing anything. You could imagine turning on a light, firing a rubber band in a node copter, turning on a motor to drive a robot forward. Just anything. Downside of this is that you're tethered. The Arduino, with that little 16 megahertz processor and its tiny memory, it cannot run Node. It's not capable of it. So you have to have it tethered at all times to a host computer that can. You can do this wirelessly, but I don't know about you, but I want my cat to be able to go out into the yard, and I don't think she's going to do it with a laptop trundling along behind her. So I want to untether her. One way I can do that is I can upgrade the microcontroller. We're going to move from the 80s to the 90s with Raspberry Pi and BeagleBone. These guys are 32-bit, oh my God, 32-bit ARM processors, and they go up to 1 blazing gigahertz of speed. And they've got memory. They've got 512 megabytes of memory starting up, and they've got SD cards. They've got Ethernet built in, as well as a whole bunch of USB. They're essentially desktop computers. They're about the size of a credit card. They fit in your hand. They're tiny. They don't take much power. That's about what a desktop computer was when I was originally thinking about tracking Poor Tab Hunter 15 years ago. And now it's cheap. The Raspberry Pi is what, $35 US? BeagleBone's a little more, 45 US. But here's the kicker. You run Linux on them. You know what this means. You can do anything. You can write any language you want. If you want to write C++, go for it. You want to write Python? Yes. You want to run JavaScript? Do it. You can do anything. Run a web server. Run your home AV system from it. Turn your Raspberry Pi into a DVR. You can do this. It's capable of it. And you still have the power of the GPIO to hook up your own hardware to it. and to extend it in ways that the original makers didn't conceive of. Oh my God, so many boards. This is like always the hard part. I have this like box full of them, box full of Arduino variants. If you come get me after this speech, I'll show you like 5 different Arduinos. Arduino is cheap, has a lot of pins, lots of hardware modules that come standard that you can attach to it really easily. If you want a prototype or if you're just getting started, stick with the standard Arduino. Get an Arduino Uno and get a bunch of shields for it. Lots of fun, easy to do. Downside is you're writing C++ or you're tethered. Then you can move up to tiny Arduinos, like the one I'm using for Cat Tracker. They can often be a lot cheaper, a lot smaller. Sometimes they're like have even wussier processors. Features vary, but they're great to put in mobile projects like the Cat Tracker. Then on the other side of the line, you have the real, sort of like real desktop computer type things in the small size factor. These will tend not to be mobile. They're too big for that, and they require too much power for that. But you can do some great stuff with them because you're running Linux. And here, I want to call out what the BeagleBone Black has. 65 pins, that's a lot. That's enough to make a model railroader happy. And they use hardware inputs and outputs like you wouldn't believe. Just take a look at a typical switch yard. If you're a traditional nerd, go for it. Go for that Beagle. Okay. You don't always have to make decisions. Cat Tracker actually uses 2. I'm going to talk just a little bit about how I designed this. I don't have a demo for you. Bluetooth really just slaughtered me. But I'll talk a little bit about what it's built from, because this is typical. What I have, there's the GPS logger. And I've got some power, enough to run it for about 16 hours, maybe a little less. Here is the Arduino Teensy. It's very tiny. As you can see, it's not very easy to prototype with. I've been soldering to those connections, just something you don't need to do right away, but because I want this thing to be like flexible and portable, I'm going to be soldering all these pieces together. There's my terrible solder joints there. And this is the part of the project I want to replace. This is the Bluetooth module. And what this does is it connects to a BeagleBone that I have sitting by the cat door. She walks past the BeagleBone. The Bluetooth modules pair up. I slurp the data from the GPS logger. I map it on Mapbox or something else, and I know where my cat has been. I envision this little cat prints like in this dotted trail across the yard. That's my hope anyway. So a really complicated project might use a bunch of these things. It's not an either or. I like to have them all in my toolbox just in case. There's some other cool stuff coming down. The next generation of devices, not available yet, though you may have seen them in their Kickstarters, the Esperino and the Tesil. Esperino is a JavaScript interpreter built to be embedded in microcontrollers. So unlike V8, it has some hope of running on those tiny things. And the Esperino board was a board designed to run it. You should be able to see that next year. The Tesil is also something similar to that. The intention is that someone looked at it and said, this Arduino is awesome, but what if I could run JavaScript directly on it? And the JavaScript, and they did it. They kind of cheated in some ways. You send it JavaScript, what it does is it jits it into Lua bytecodes, and it runs a Lua interpreter. Lua is another one of the, it's much more easily embedded than JavaScript, which was never designed for this. So they do this little, wonderful little cheat that I'm really looking forward to using. Next year, though, not yet. Okay. Now you know what a GPIO is, and you know what you can do with it, and you know that Johnny 5 exists. What's your next step? Get the Spark Fun Inventors Kit. Or if you're a little bit nervous about that, go to a NodeBots Hack Day. People will have tons of stuff that you can borrow and play with at a NodeBots Hack Day. Borrow an Arduino. Check it out. See if this is for you. See if your dream project is a possibility. You want to put a video camera on your dog? Hey, maybe you can do that at a hack day. Do you want to figure out how to put a moisture sensor in your garden? You can do it. There's another great URL. This was announced just last week. It's the Arduino Experimenter's Guide projects in JavaScript. in Johnny 5. Now this, if you're just getting started, this is amazing because this takes you through basic circuits and basic projects, and you build them one at a time, and all the examples are JavaScript. They're all doable with Johnny 5. So if you're still allergic to C++, as you probably should be, this is how will get you going. When you want to know why there was a resistor in that circuit for the buttons and the LEDs, which you notice it's there, but I didn't tell you why. This is your book. Practical Electronics for Inventors. This probably has more information than you need, but if you want to know how electricity works beyond just the basics of share ground and complete your circuits, here's the book for you. Experiment. I actually buy 3 of everything, 1 to prototype with, 1 to destroy by accident, and then 1 to put in the final project because I have melted things. The first thing you will do is actually you will make that circuit with the LED without the diode, and then without the resistor, and then you'll smell this like, do I smell burning plastic? Yes, you do. You just killed an LED. It's okay. It's totally okay. Most of this stuff is cheap enough that you won't cry, and once you've done a little bit in this, you probably won't be making too many of these mistakes. Okay. My other recommendation to you is that you not be scared of learning strange new things. The world of hardware will take you into a world that's adjacent to what you've just been doing. Do you know how USB works? Do you know what your USB library works? You plug things into USB every day. Do you know how it works? Guess what? It's just software. It's just a library with a bunch of trivia that you have to learn. It's totally accessible, as I discovered. I got a little bit into quadcopters earlier this year, and I got this tiny little quadcopter called the Crazy Fly. And I said, this is awesome. I'm a terrible pilot of this tiny quadcopter. I wonder if I could control it with software. Oh, all of its software is written in Python. Do I really want to write Python? Maybe I could write Python. Oh, look at that event loop. Ooh. I'm going to rewrite this in JavaScript. So I did, because I'm stubborn. I rewrote it in JavaScript, and in order to do that, I had to interact with the Crazy Fly radio, which sends and receives commands over USB, which I knew nothing about. Guess what? It's just software. You can learn it. I learned it. Go forth, figure out Bluetooth, do it, reverse engineer something. You can do it. And it'll be fun. At the end of it, your dream project will be achieved. Go forth and build. Just try it. If you have questions about this stuff, I have a bag full of BeagleBones, Raspberry Pis. I have some Arduino variations and some jumpers and stuff. I have a leap motion you can play with as well if you grab me on the lunch break. Go to the next NodeBots event in your city. If there isn't one, organize one. Have fun. Thank you.